I want you to see and visualize the top, how the steel is at the top. Now there's some cross steel here. It's going to really help out resisting what I wanted to do. But I want you to visualize the steel is inside here, and all it has to do is lift up. As this goes down, let me see if it's in the view. A little bit, let me zoom out. Okay. So as this goes down, our antennas are going to look like that. All right, they slip off, they get a butterfly in the middle, they slip off and they go there. I'm taking some liberty because I'm not putting concrete across the head. But let's see what happens. So there's our butterfly, our beginning of our butterfly, and you can see it already with the rabbit ears. I mean with the roach antennas, and there's your butterfly in the middle. Now you can see what's going to happen when this goes down. The deflection in the middle, this rebar is no longer engaged. Let's take it down. And there's our rabbit ears. And so in this video right here, you can find it on the channel still, titled right here. Here are our rabbit ears, rabbit ears, and then there's, so I use it in a mix, right? When you make up words like that, make up names, help you memorize it. Sometimes I make mistakes still. So our little antenna, our two antenna up here. We did the video showing the previous, how the rotation happens here. But there are the ears showing the deflection in that part. We talked about the rotation here, and then these ears over here is how it pulled off on that side. This reinforcement, how it's parallel and on one face, telling you that it draped like I just showed you. Let's go from here. I mean your roach antennas sticking up. So you got this deck deflection in the middle that fails, that pulls. It doesn't have the other engagement of the concrete on this side to hold it, on this side, the negative side, to hold it up. So it just strips out of the concrete on that side. And I can do a third one also and show you the three of them interacting together. But there's your butterfly, there's your antenna. Sorry about the lighting, it's getting dark. I just wanted to get you some content. So there's your antenna. Roach antennas, butterfly. Roach antennas and butterfly. All right. So now I'm going to show you how we're going to increase the heads of these, the critical shear area. How we're going to increase the heads in the next part of this video. Okay guys, let's see. I'm going to make you a ledger. And I think I might just use one bolt hole. I'm not sure. Put my safety glasses on. I think this should do it. It won't go into it. Bites into it. Yep, beautiful. Beautiful. Let's see. When I move that, so we're going to use one bolt, I think, on this whole system on this side. But when I remove it, we should see that I didn't do too much, that I didn't go through. Just barely took the paint off, huh? It's not bad. Not bad. Should have me remove your cast for you. I can remove cast for you. Yeah, really a discounted price instead of going to your doctor. I'll saw it off with a power saw. I'll know when it's through, and if not, I'll give you money back if I cut your arm or leg up. I'm not limiting right now to just arm and leg. Sorry, guys. If anybody else needs like body cast, stuff like that, I don't feel confident enough for that yet. But arms and legs, yeah, give them up. All right. So now I'm going to mount that onto there. It's just going to be a ledger onto the face of there. Let me move this out of the way for a second. It's pretty darn expensive, as you guys can imagine. What I'm going to do is on this end, it's already has a plate on it, welded on. That end will be mounted on the plate. It's mounted on the plate. On this end, I'm going to mount it on the face of this. And then we're going to put the steel across it, and then we're going to load our floor on it. So on this one, I'm just going to put one bolt. Just one bolt right there. I'm sorry, we'll bring it up to here. And then we're going to put this floor on it, where it will still reveal some, so you can see it's not connected, not on top of this column. And my intent is to show you that the, right, so I need that steel to lay flat. Oops. Okay, let's go ahead and drill this thing up. See if I can get this right. This is the electric one. It turns out it uses electric to work it. Of course you can't tell it. Okay, so you guys, it's another video about how I show you how to make things disappear right in front of you. So there's the one, bolted up. Tighten it up so it doesn't rotate as much. Okay, so now you see the concept behind it. That's the concept. Simple. Of course, this would be the other direction, and you could do it out of aluminum. Ledgering it, but you use aluminum, be much lighter, and you would headroom. You could add a lot more of these than one piece. In other words, instead of a 2x10, let's call it, you would use a 2x4 and use 4 of them in a row next to each other and get the capacity without losing headroom for vehicles, for example. And it would be lightweight. You wouldn't have to worry about corrosion. You would have to worry about corrosion as far as your anchors. Make sure that you stay compatible. That's aluminum. Of course, you can use steel. You can use galvanized steel also. Now, we get the machine, we put it on top of there, we put the load on top of there, and we can see that the deflection won't take place because the steel is now there. This is what I'm talking about with the concrete. So you retrofit, this would be the deck. You'd retrofit this under here, steel, just like this there. And now you would grout it to the underside of the deck. This is the concrete deck. You'd grout it to the underside of the deck. Pretty look. So you grout it to the underside of the deck. And as you can see, these aren't even connected. Yet it's not, here's a full break if you will, and it's not going down because you've now reinforced it with steel. It would be, like I said, you would use like this, a beam like this. So you see how conceptually this works. There's your column, support ledger, underside of it, grout here. You don't have to make this perfectly even with there. It can come up short, and you would grout it, and it would then transfer the load or be redundant with the load going onto the steel. And that steel would be under here. Aluminum or steel. Oh boy. Hopefully you guys can conceive the concept. It's the ledger though that I want you to really conceive. The ledger system. It now doesn't care about whether you have heads or not, because this steel will be wrapped around the column, making a larger critical shear area where the loads where you would pick up the loads. So it doesn't care. Make sure which part of the video you can see there. Yeah, you can almost see it. So it wouldn't care. Okay, I gotta zoom out. If that's steel, you see the steel antenna, how short they come up? This system doesn't care if the steel is up here and trying to hold this deck together or whatever it is. It's redundant now. It's a retrofit to support the system here. And now, let's say you've got the mid-span issues. You can make this steel larger, and then use steel going across from one column to the next to try to break the loads up and come across again. So you can use Smaller steel. You still got to worry about the headroom of the vehicles, right? But safety's first. So if you got to restrict some car height in there, which they do anyway, then you just restrict it. In other words, if your spans are too large, then you're screwed. This should be this would be your primary load. Then you would think of this as your primary load, and you would think of all your heads have failed, 100% failed if you were to design this system. You would think of it as the rebar still works in the deck to some degree, but the heads and the critical shear area has failed is what this concept is trying to resolve. Let's see if I can grab another piece of steel and help you understand the ledger, help you visualize more. So this would wrap around here. This becomes the new head. The critical shear area, the head, and this extra lip becomes it. Now you could make it much larger, as you can see, and then brace it back. You wrap it around. Now you've got this much larger head area here, bracing back into the column. This gives you a much larger critical shear area to avoid punching shear. Hopefully that last image gets you a better idea. Remember the bracing on it. Well, we'll see what my video does. I'm terminating the video for now. I might have to really make up a different mocked up model. This stuff takes a lot of time.